Okay, it's time for part 2 of the story of the transfer case rebuild. It's a long story, but bear with me, folks. After I rebuilt the transmission, the transfer case, I started to realize that the seal that I worried so much about damaging, I managed to apparently damage it. You can see it's pretty wet down here. It doesn't lose a tremendous amount of fluid, but you can see it's flying back, hitting the exhaust. Things are nice and greasy. So basically I've got to pull the transfer case apart, pretty much repeat my last process. In addition, I have learned a whole lot about the bearing preload of the bearings I replaced in here. And I'm realizing that even though I didn't really check them closely after I put them in, they were probably tighter than they should have been. So I'm going to be adding a lot of information on this video to supplement the previous transfer case rebuild video, so that once you watch both videos, you're going to have an absolutely good understanding of the entire process, including making sure the preload on the bearings is correct and getting this seal in and out, or in, without damaging it. Now, to that end, I'm going to take this apart. The thing I'm going to do different is I'm going to remove the right front exhaust system, which will give me room to move the front drive shaft out of the way to get it removed without any difficulties getting it back in. It's, for those of you who may have attempted it, it's extremely difficult, and in fact in this car it's impossible to get in with the output shaft in place in the transfer case. So it had to be, you had to wrestle the output shaft into the front prop shaft or drive shaft, and doing so is just more than the seal can bear. Apparently it's just too much stress and too much flexing. So this time I'm going to drop the front drive shaft. Let me get started, do all the things you've already seen, drop the plastic panels, the cross brace, the transmission mount, get the floor jack under the transmission so it's drooping down appropriately, and remove and move back the rear drive shaft, the prop shaft, as well as these nice silver heat shields that are in the way. So I won't bother you to make you watch that again. Watch the first video if you want to see how it's done. Okay, and being proactive, I've decided I'll definitely be needing another one of these $50 bolts that you heard so much about, as well as I got 2 of the seals just in case I happen to bugger one up. They're only about $5, so it doesn't make sense to take a chance. And then a whole new array of Timken bearings and races. Might not need them, but by gosh, I'm going to have them just in case I do. Also, of course, more transmission fluid, although I probably have enough left from the old jug. And I did get a new micrometer. My old one snuck away somewhere, so I had to buy a new one, which will come in awfully handy when measuring shim width for preload. You'll see more about that later. Okay, one of the other steps is to remove the front drive shaft. I just buzzed it off with an impact. If you don't have an impact, you just use a T55 Torx socket bit, and you have somebody stand on the front brakes if you got the front wheels up in the air, and that will keep it from the differential from rotating, so you can take them out. Obviously you gotta have them release the brakes to rotate it to get to the next bolt. But the next step that I'm going to do is drop the exhaust, which is going to require removing both of these O2 sensors. Keep in mind, see the green wire goes to the front one, the black wire goes to the back one. That will be important when you put them back. The thing about the routing for these is it's a little fiddly if you try to remove the entire O2 sensor. What I'm going to do is I'm just going to spin them out and leave them dangling. They won't be in the way, and there's plenty of loose cord up to the first connection to the body, so you don't have to worry about that. But now all I need is a 22 millimeter opened end wrench, and I should be able to get to both of these. Okay. And these were both, this is pretty easy to get out. Both of these were replaced as part of the original repair because the front drive shaft had taken out both of the originals. So these come out easier than some might, but you probably won't have any trouble getting them out. Okay, we got one dangling. And the front one is a little bit harder to get to. Worst case, you could actually remove it after you drop the front part of the exhaust, which is a lot easier than you might think, because it's held in with two bolts, which you can kind of see. You can kind of see one of them there. They really don't come out all that hard, and that frees up the front end of this. I'm going to try to release it rather than bring this whole bracket down. I'm going to just try to release it over here so that I can get as little out as necessary, just to get, and this is all just to get room to move the front of this drive shaft around enough to get it in and out, believe it or not. Great job, Mercedes engineers. Okay, the front one's a little trickier to get to. I managed to get to it. You may have to drop the exhaust first, but it came out. It's partially because it was so easy to get out, because it was new. Now the next step is I'm going to reach up in there, and I believe it's 13 millimeter bolts that hold the front end in, and you can see one there, and there's the other one. They're really both pretty good access from down here. I think it'll take a wobble on both ends just to get the angle, particularly on the inside one, because of the heat shield here, and the firewall is a little bit in the, or not firewall, just this heat shield is a little bit in the way. So these two bolts have to come out, and the I'll show you later, the rear clamp that holds the front and back half of the right side of the exhaust has to be loosened as well. Okay, next step is to take that inside 13 millimeter off. The axis is actually pretty good. What you want to do is just use a wobble. In this case, I'm using a 3/8 inch drive, and with a wobble on the end, which gives me the right angle. It does take two hands to turn it out, so that's what I'm going to do. I'm going to put the camera down. Okay, easy peasy. That one came out pretty good. Now it's just a matter of getting the outside one, which is actually a straighter shot. Again, that's going to take two hands, but that's just straight up with a extension and back it out. Okay, these should come off easily. If your car has the unfortunate reality of living in the frozen north, you may have to apply some penetrating oil or something to the nuts. In this case, this is pretty much a lifetime Arizona car, so it's really not difficult to get something like this off. Eat your heart out. The next trick is to just remove the clamp from the midsection. You'll want to get it pretty loose. To be sure you can get them separated. Now the trick about this one is that the move that back. This one actually overlaps. This one, the pipe actually extends into this rear box a good bit. So I'm probably going to have to wrestle the whole thing up and forward to get the clearance to clear this end, at which point it should just pretty much come out. So that is what I'm going to try to do. Alright, now the trick is, won't be pretty, but just lay under it and see if you can get the clearance, which may be kind of a neat. There it is. Oh, easy peasy. Okay. The exhaust is well and truly out of the way. Okay, now I'm going to try to droop the back of the transmission transfer case. I've got it up actually just a tiny bit higher than it normally rides. To get the clearances, to get the front drive shaft out, and also to get to everything you need to back here. And just slightly release the floor jack. And you can see the whole thing coming down, including the rear, the rest of the exhaust, and everything else behind it. So, okay, that should be enough. You don't necessarily need to droop it any more than you need to. You just want to put extra strain on these motor mounts because they're such a pain to change. Okay, with that done, there's enough room to get the drive shaft twisted up in there and wiggled forward, which frees it up in the back here. You can kind of see it coming out. The light's not too good, but basically just got to work it forward enough, find a path up there to get it moved up and forward. May have to do a little more adjusting to the attitude of the transmission. It's still a little tight. Well, let me see what I can do with two hands. Hey, still struggling with getting the drive shaft out. It's always the simple things. I have pried the rear of the transfer case over toward the driver's side, left side of the car, and wedged a piece of wood in there to hold it in place. That seems to give me a little more room. But right now, believe it or not, it looks like what's holding it up is this E-Torx bolt right there that apparently serves no other function than to hold that line in place. So I'm going to remove that. You can see how the bottom of it's buggered up. That's from the top of the drive shaft. I'm thinking with that out of the way, I might just have enough clearance to swing the drive shaft up and get it over the top of the differential and out. Okay, a little secret about these E-Torx bolts. Even though you got this exotic looking head, in a pinch, and this is a pinch, you can use a regular wrench. In this case, I'm using an 8mm closed-end wrench to get on the E-Torx bolt and turn it out. Again, I'm having trouble showing it because of the angle and the lighting and the shadows and general aggravation, but you get the idea. So I'm going to back that out and we'll show you how it changes things. Okay, happily, that removing that bolt actually did give me that little bit. I was able to move the top. You could see it just cleared that little nub on top of the differential, which freed it up here. I pushed and pushed. It didn't do any good. What I ended up doing was just putting a pry bar back. I slid the rubber boot back toward the transfer case. I was able to access this lip. I just tapped this pry bar with a 3-pound mallet and it slid right up and off. So I'm going to call that a win. So now we have the drive shaft is loose-ish. I may actually try to put that bolt back in before I put the drive shaft in because I'm hoping I'll be able to do that, so just to make putting that back in easier. But if not, not going to be the end of the world either. Okay, what that's done is it's freed up this output shaft here to not be fighting the drive shaft when I reinstall it, so it doesn't tear up the seal again. And the next step is going to be to start the process of draining the fluid. There's an extra drain plug back here on the transfer case, so you don't have to drain the entire transmission just to work on the transfer case. I should get something less than a quart out of that. I'll just let it drain overnight, and I'll go ahead and remove this block of wood because it is really going to be in my way otherwise. All right, wood's out, plug is out, and it's draining, and I will come back and work on this tomorrow after it's had a chance to get all that fluid out, which by the way still looks really clean, and again, as expected, something less than a quart in there, so we're good to go. Okay, one of the time-saving tricks I've come up with is to, where access is a little tight, is I use an 8mm socket in conjunction with just a little hex drive Torx bit to reach those transfer case bolts that are a little tight. Both the rear case and the mid case can use the same thing, which is a little easier than using the fatter 1/2-inch drive Torx bits that I used previously. Okay, this thinner, you know I'm not using my 1/2-inch drive here. You can see how much better the access is to these bolts and the hard to reach parts are. And that's going to be doubly important because this mid case is going to go on and off several times during this this process to set the preload. So you want every advantage you can get. Alrighty then, the mid case is off, came off easy. You can see that it doesn't look like that, even with possibly a little too much tension. I think you can see a little wear on the races. Bearings actually look really good. I'm fairly convinced that it was going to probably last a long time if it wasn't for that seal. So next step is to remove the two helical gear clusters and get them on the bench and take a closer look. And this is what I saw when I pulled out the lower one. It's clear that I managed to bugger it up whenever I was installing it. I don't know if you can see that. Let me try to get a little more light on it. But the spring that's supposed to hold the tension is got a good gash in it, so somehow I got to that. And I was being very careful, so be warned that that whole process is finicky at best, and so that's why I decided to drop the drive shaft out this time, so that it would be less of a fight to get it in, and hopefully not experience the same thing next time. Okay, a closer look at the bearings. I think that little bit of stuff you see around the top there is just probably from driving it in. Those look really, really good. You can see where the bearings have been running. Clearly there was some tension, but by all accounts I'm not seeing anything that indicates there was any kind of fatal kind of pressure on these bearings. They look really good. I'm actually thinking I'm just going to reuse these bearings rather than bother to press them off, press the new ones on. One thing I am planning to do is to go ahead and put these all in my 12-ton shop press, just to make doubly certain that they are pressed all the way down. They certainly look like it, but the differences between too tight and too loose are measured in tenths of a millimeter, so it would sure be easy to miss that by eye. So I'm just going to double check to make sure that I've got these things seated fully, both the races and the bearings. And one thing I did notice, the indentation down there, that's actually from the bolt that goes in the end of the bearing race driver I used to drive this in. That leads me to believe that it is possible that the contact that made kept it from pressing this bearing entirely home. Maybe, maybe not, but that's one of the things that I will double check by pressing everything home with a shop press. Okay, and here we go. Just providing a lot of pressure to press these bearings absolutely positively home. This is just to make doubly certain that they were installed properly the first time. Okay, similar process using a 12-ton press, pressing the race into the mid housing. Again, just to make doubly certain that it's fully seated and that there's no possibility that there was a fraction of a tenth of a millimeter left in gap. Now I just have to repeat the same for the other side using the race drivers from my kit that was in the previous video, of course. Okay, for the other side I had to put it in at a little bit of an angle because that race, like the that cluster that sits in it, is at a bit of an angle, so I had to kind of improvise, but it's pressing it in square now. That should be plenty of pressure, and we've now ensured that all the bearings and all the races are fully seated, and we're ready to start testing the preload. And I should mention I am leaving the seal in place. My thing is buggered up. I'm leaving that seal in place, taking the obviously damaged tension spring out of it, because I don't want to risk the new seal for the times I'm going to be putting the gear cluster in and out of this thing. So I'm going to do all my testing with the existing silicone. You can see it's still on the front case. It's interesting, most of it's stuck there instead of the back case, but whatever. I'm leaving that in to replicate the width of the new sealant that I'll be installing. And then I will insert each of the gear clusters separately, rebolt and torque down the mid case, probably not all the bolts, probably a little over half of them in each case, to make sure that the tension is proper. And then I will test the rotational torque it takes to move the gears and see where we're at. I went searching for information on the preload on these bearings. I couldn't find anything specific to the transfer case, but I found a lot of information on the Timken, the manufacturer of the bearings, on their website. It's relative to pinion bearings, which are precisely the same. They operate in the same kind of environment. So this will apply to pinion bearings, but will be entirely applicable to the transfer case bearings of the same format in our GLKs and other Mercedes. In this case, they're showing you the effects of the preload, which is this side of the graph, versus the end play of the bearings. So basically, preload is whenever you're applying pressure end to end. The bearings are tighter in the races. End play means there's zero pressure on the bearings when they're not being used and extending this way. Now, confusingly, they did the graphs the opposite directions, so don't let that surprise you. The end play on this graph is over here. Now, the thing to notice is that the entire range here, and I showed this one because it's really better at showing some of the aspects of the preload, but it doesn't really give you a lot of details. But we're talking 0.1 millimeters preload, and you're only down to about 0.15 millimeters over this entire range. So it's a quarter of a millimeter range from one end to the other. So you can see it's very precise. And if you go over here, this is kind of the sweet spot that you want to be shooting for here. And you can see the optimum setting down here, and it encompasses probably a total width of about 0.1 millimeters, and that's the total stack up between both races and the bearings. So it's a pretty tight target we're shooting at. The important thing is, though, that you understand you're looking for a certain amount of preload on the bearings to keep the bearing life up here as much as possible. Now notice this graph does show a lifespan. Now this 5,000 hour lifespan is significant because that translates into probably a couple 100,000 miles of life for our application. Maybe more, maybe less, but it's a long time. So you can see that if you look at the points here, we're looking about 0.4 millimeters, and interpolating this, it's about 0.1. So about half a millimeter of range here will take you from dangerously tight to dangerously loose. Although you can see this side of the curve is very a lot more gradual. So if you land somewhere in here, you're going to be fine. Our goal will be to hit as close to this as we can. I'm not sure it's realistic to expect to be totally in there. Now the thing is, there's no way to directly measure the preload in our application because the whole thing's bolted together, inaccessible. The one thing I was able to find on how to do the preload, which, as you can see here, this shows you the preload as effect on the bearing operating settings, basically how much of the bearing is in play under various conditions. You can see in heavy preload, the entire bearing is constantly under stress. Extreme unloading will just have the bearing relying on, it'll just be laying on its bottom rollers. And this is pretty much zero clearance, zero preload, zero end play, and it reduces the amount of the bearings in play. But at any rate, what I really want to show you is this graph. Now this is put together from Timken information, and they supplied basically this part of the graph, which I've put in this format just to make it a little more understandable. I did some analysis on the numbers, and they look pretty linear, so I extended. These are my numbers, so take them with a grain of salt. Basically, you can infer the preload by measuring the rolling resistance of the bearings. So in this case, that would be each of the two assemblies in the transfer case, the rear output shaft and the front output shaft, measured individually. And I'll mention this with new bearings. This is all based on new bearings. If you're measuring old bearings, you would basically divide these rolling resistance numbers by about 2 to get the same kind of information. But we're going to assume we're measuring new bearings because, well, that's what we're working on. So, for example, if you put your case together with the rear output shaft in place and you measure it, which is I'll show you how to do in another part of the video, or maybe you already have. Say, for example, you measure 40 inch-pounds, or let's say, 40 inch-pounds of resistance on that one. Okay, according to Timken, that would translate into a thickness of 0.43. Now, this information is a little arbitrary in that it's based on a standard thickness and the adjustment you make to it. But nonetheless, the important thing is we have a reference number. Now, in this case, based on information I could get online about the operating parameters for very similar bearings in a pinion application, it looks like 20 inch-pounds would be a really good target. That's kind of in the middle of the range. They vary up and down 20, 30, 40%. I don't think that's going to be significant in our case, so I just use 20 inch-pounds. But say, for example, you measured 40, okay, which corresponds to 0.43 millimeter, and you're shooting for 20, which corresponds to 0.28. Okay, now some quick math tells you that you've got a 0.15 millimeter delta between those two. So what that would indicate would be that you would want to reduce the preload by 0.15 millimeters, and in this case that would mean removing one of the end race spacers, measuring it carefully with a pair of accurate calipers, and sanding, machining, grinding, whatever, it down 0.15 millimeters until it's that much thinner. And theoretically then when you put it all back together, you will have moved the bearing rotation, the drag down here, which should indicate that you've got the preload right. Basically, if we get it close, and I would err toward the lower preload side, if anything, I can rest assured that the lifespan of the bearings is going to be plenty adequate and should outlast the rest of the car. One other thing I wanted to add is that I did hear from a guy who was reportedly a Mercedes dealer tech, who said that whenever they got in fried bearings, well, he thought it was all because of bad home maintenance. I don't buy that, because I doubt very seriously there's a lot of people out there DIYing this, and the bearings would have had to fail anyway. And based on his input, their standard process is to add a 0.5 millimeter gasket between the transmission case and the front transfer case housing. Now that kind of makes sense based on the fact that if you look at this graph, if you look at where it dips down below here, it's about 0.1 millimeter preload. So 0.5 millimeter will move the preload all the way over here. Now, add in the fact that a 0.5 millimeter gasket is going to compress a little bit. So based on that, you're going to assume that the bearings failed because they were living over here to the right of where this line dips under the 5,000 hour line. So if you figure you're left with 3 or 4 tenths of a millimeter of extra, basically reducing the preload, you're going to be moving it into the safe zone over here somewhere. So that kind of makes sense. I don't want to do it that way just because of the variability in the gasket, and I really want to understand exactly where the preload is and try to get it spot on. But that is an option you could do on yours if you clearly end up with, maybe after replacing the bearings, it's just way too tight. You don't really have the ability to do scientific measurements. You might try the 0.5 millimeter gasket trick and recheck and see if the bearings get loose enough to spin easily by fingers, which would indicate it's, based on the graph that I created, the preload would be in an acceptable range, somewhere in this this sweet spot over here. Okay, the next step is to torque all of these bolts to the specified torque. In this case, it's about 14.7 foot-pounds for the bolts you put in. I can tell already that the gear cluster is too tight. I mean, I can rotate it by hand, but it's much more difficult than it should be. That tells me the preload is far too high. The trick is going to be measuring it and working out something that I can use my 1/4-inch drive beam style torque wrench to turn that shaft so I can get a starting reading. Okay, try as I might, I really can't come up with a way to connect this to my torque wrench. Best I'm going to be able to do is just, you can see I can turn it, I can grab it with my fingertips and barely move it, but good solid twist, it will definitely rotate. Clearly more than the drag that I would want as an ideal, which, as I mentioned earlier, shooting for 20 inch-pounds of rotational torque, that's after breakaway and once you're turning at about this kind of speed. It's not horrible, but it's certainly clearly well above 20 inch-pounds, although it's not horrible. I'm going to try to use a similar sized device on my beam style torque wrench and calibrate my wrist. That's the best I can do. It'll at least get me in the ballpark and let me know how I've got to shave down the spacer under this race in order to reduce the preload on this bearing. Okay, I came up with this little arrangement with my little 1/4-inch beam style torque wrench. This is approximating the size of the shaft on the gear cluster, and twisting it with what feels like the same amount of torque gives me about equivalent of 30 or slightly over inch-pounds. And again, because this is a used bearing, the goal is about half of what a new bearing would be, so I would be shooting for 10 inch-pounds rather. Coming over my little chart here, that's all the way at the bottom. It corresponds to a 0.2 millimeter adjustment. Again, don't worry about that number. What matters is the difference between that and the actual. So if we go up to 30 and go across and come down, we get like 0.3, let's say 0.35 millimeters. So I'm going to subtract 0.2 from 0.35. I get 0.15, which tells me I need to reduce the width of the spacer under this race by about 0.15 millimeters. So let me take it out and start working on it. As in my previous video, I'm just going to use a small drift to tap out the spacer and the race. Again, don't get in a hurry. Just work around the periphery and make sure you don't get it in there sideways. Okay. And there's my spacer. And now, trick is, let's take a look and see how thick this thing is. It's measures 0.26 or 2.5 millimeters rather, which is pretty much what I expected. Okay, so based on my calculations, I'm going to take this down to 2.35, which is somewhere between 2.3 and 2.2. Won't be super precision, but a little less will definitely get us closer than we are now, which is what matters. Alright, there are a lot of ways to skin this particular cat, but in this case, I'm just going to try to make it as easy as I can on myself. Use just a regular sander, electric sander, and use it to take down the circumference, and I will just rotate it to make sure I don't end up taking too much off one part and not enough off another. The process won't be precision, but it'll certainly be close enough for what we need to do here. Many minutes of grinding later, these are pretty tough. They're pretty strong steel. I'm down to right between 2.4 and 2.3 millimeters. Actually, it'd be better if I had a caliper that read in hundredths, but I'm confident this is right about, I've taken about 15 hundredths off of this. Based on the readings I'm getting around the circumference between 2.3 and 2.4, where it was previously at least 2.5, so that should be good, enough to bring the preload down to the kind of range I want to see it in. Alright, now the trick is just to press in the race and the spacer as previously done. I'm going to do that on the my 12-ton press instead of using my driver, just to make it quicker and more efficient. It literally took less than a minute. Looks good. It looks in there solid. Now the next iterative stage is to reinstall the same gear cluster and do all of that again and test the results and make sure that I've got something close to my 10 inch-pounds of rotational torque, which would indicate the right preload. So let's get under there and get it done. Okay, we're back together. Bolts in, torque to spec, and as you can see, I can now easily spin the shaft with my fingertips. Again, I'm having to, because I don't really have a way to grab this with anything I can connect to my torque wrench, I'm having to estimate it, but I got to tell you, that's got to be fine. I mean, that's spinning free. Presumably it will, if anything, get a little bit looser as it beds in. It's much better than it was. I'm sure it was under a lot more tension than that originally. And keep in mind, it has about 2,000 miles on these bearings and these races. And I'm sure under more preload than it should have, without doing any discernible damage to anything. So putting all that together is just my long-winded way of saying I think this will work just fine. Now, all I have to do is take it all back apart, put the other shaft in, the front output shaft, and do the same process all over again. Hopefully this one will be a little bit closer to start with, so I don't have to spend so much time grinding the spacer down. Okay, funny enough, I got this bolted together, and it is just really basically impossible. I don't have a very good grip in here, but it will not turn, which tells me the preload is obviously way too high. So the thing I'm going to do is take some arbitrary value off of the spacer, the same way I just did for the other gear cluster. Obviously it's going to be more than 0.15. I'm thinking probably, I'll probably take like 0.3 of a millimeter off to start, put it back together and see where that gets me. Essentially it's going to be, I can see it's going to be very difficult to get any kind of meaningful measurement trying to spin this one by itself because of its location. There's really no way to get anything up there, I don't think, because I can't rotate it because of the tightness in this area. I will get it finger spinnable, and at that point I'll put both clusters in and I'll be able to infer the rotational drag of this one, finger tension wise at least, by spinning both of them together. Once I get both of them to the point where I can spin it with my fingertips on the big cluster here, I'm sure it's going to last longer than the rest of the car, and at that point I won't worry about it. Alright, and this one's a little more finicky to get out. You gotta basically just pry it out because there's no access to the back side. So just a matter of catching it with a tool like this. Again, watch the video, the original video, and you'll see in a little more detail how this is done. So it's coming up. There, I'm getting a okay, 0.26 millimeters as my starting point. Can't see it, sorry. Getting 2.6, there's a little burr on it there that you're reading. Okay, so starting from 0.26 millimeters, 2.6, I'm going to go down to 2.3 as a starting point. Same process as before, grinding it down, long, slow, ugly process. Okay, many minutes later, I end up with a 2.3 millimeter spacer. So hopefully that's going to be enough. I'm not being very scientific about it. I hope this does it, because if I need to take off more, I'll have to remove it from the housing the same way, which I prefer not to. So I'm hoping. Okay, the race is pressed in, nice and smooth. Both are in, so I'll reassemble it. Hope for a much better outcome. Okay, I just got it pushed together. Don't even have bolts in it, but the first check is to just give it a spin. And it does spin easily, so that's a good sign. Now I'll start putting in the bolts and torque it down and see if it gets a little bit tighter. Okay, got it in place, snugged it down, and it's much better, but it's still absolutely too tight, which means I've got to pull it back out, machine it down some more. Since I took it to 2.3, I'll take it down to just over 2 millimeters and try it again. Nobody said this was going to be easy. A lot of grinding later, we're down to 2 millimeters. That hopefully will do the trick this time. Got it all bolted up, everything torqued to spec, all the bolts around the periphery of the front output shaft, and now I can reach in and spin the gear through the hole here. I can spin the helical gear directly, or I can grab the output shaft here. It's difficult because of the angle, but I can spin it with a little bit of resistance, which I would say would probably be pretty close to that 10 inch-pounds of torque that would be typical for a used bearing. Again, I did not swap out the bearings, so I'm going to call that a win. Now I'm going to take it back apart yet again. I'm going to drive in the new seal, clean up the housing sections, and start assembling it for real this time. Okay, it's time to drive in the new front output shaft seal. I've greased it, both the inside and the outside. The outside to drive it in easier, the inside so that the seal won't catch on the output shaft nose whenever it goes through, so it slides through easier and hopefully will not deform. So now I'm going to drive it in, just using a driver, and I will do that with two hands. Okay, the surface is cleaned up. Now it's just a matter of cleaning up the two gear clusters and seeing if I can insert them so that they will stay in place while I place the mid case. Okay, as hoped and expected, I placed the rear output shaft first, and then by carefully placing the front output shaft, sliding it in at the angle to follow its path up to the front differential. It stays in place while they're waiting for the mid cover to go on. So now I'm going to carefully put a bead of sealant on the mid cover and ever so gently place it over these two without knocking them out of alignment. And if I am successful in that, I will have not damaged my front output shaft seal again. Alright, somehow the camera failed whenever I was placing this, but basically I was able to place the rear cover on without dislodging anything. I was very, very careful about it. Check to see everything's still rotating smoothly. You can hear the front output shaft flopping around, but other than that, it's all as expected. So it's just a matter of tightening down all the bolts, which I have now placed, and then torquing them all to spec and double checking that the rotation is still within basically finger rotatable. So let's get on it. Alright, all torqued to spec. Now it's a matter of putting this back together, checking the rotation, and it's beautiful. There's again, I wished I could wish there was a way I could give you a little more scientific analysis of this rotational force, but it's firm but easy enough to rotate by fingertips. Certainly within reason, within the point where I am sure it's going to be fine for the duration. So I'm a happy camper. And for what it's worth, I'm checking the front based on the way the gear cluster went in, nice and straight, absolutely no stress anywhere, because I wasn't fighting the drive shaft itself. I was just double checking to make sure there was no evidence of any displacement of the front seal, and it looks absolutely fine. So I'm 99% sure that that is now fixed, so I no longer have to deal with all this kind of stuff. The leaking tranny fluid all over my Mercedes. The one exhaust side out here does make it a little bit easier to get to things. And so like for example, placing this rear output cluster here. This is the part that contains the planetary gears that allow the rear drive to turn at slightly different speeds than the front under different conditions. So it goes in next, followed by the application of that $50 bolt, which I'm really getting tired of buying, by the way. Okay, this can be a little finicky to place. It's got some grooves on the back. It's got a bunch of little tiny planetary rotational gears inside that all have to find their perfect rotation, perfect orientation in order to slide on. I've found that it's just a matter of just keep working it. It will eventually find its way home. There we go. torque to 22 foot-pounds for the first stage, which I'm going to use a beam style wrench because I'm kind of old school, and I'm doing a $50 bolt, I just like to make sure it's right. So there we go. And the next stage is to torque it an additional 180 degrees till its final resting place. So I have a special ratchet I use for that. Okay, you can see this one has you can see the tail shaft, and it gives me a visual indication of how far the socket has been turned. So there, that's 180 degrees. All right, now it's a matter of just placing the top plate on and the C-clip. All right. All right. And that is how that is supposed to work. Okay, all that remains now is the back case. So I'll go, it's already cleaned, I'll prep it with sealant and install it. And a little helpful persuasion where necessary. There it goes. Okay, now it's getting close to contacting. I'm going to put a couple screws in just to keep it from rotating at all. That ought to do it. And good. Okay, and all the rear housing bolts now get torqued down to about 6 foot-pounds, which is not much. So folks, don't get carried away here, or you'll do some damage. So. I am going to reuse, not always advisable on some axles and similar applications. The difference here is that the peening that holds the little dimple in the little notch is not on a threaded area, so there's no damage to the threads when you take the nut off. So it can be reused at least a couple times, which is what I'm doing. Okay. Okay, the first step is to slide the little bellows seal onto the output shaft, because trying to slide this drive shaft, lining up the splines with the splines on the output shaft is tough enough. And also, you notice you can rotate the output shaft with the rear output yoke and in this case I'm going to rotate it so that one of the thick splines, the locating spline, is straight down. Okay, you can see the thick spline to mate is at the top. They're 180 out, so there's one at the bottom. You can't see the ones that match, but you get the idea. So now it's just a matter of sliding those two together, and hopefully the rear, the front end of this will clear the differential while I'm doing that. That's going to be the interesting thing. So let's see how that goes. Okay, I had to drop the transmission jack, the floor jack that's holding it up, down a little bit to get the clearance I needed. It appears to be more or less lined up. As expected, the front is a little bit hung up on the differential. The basic problem you can see is that this is maxed out full up, and the angle that the drive shaft is approaching from is just a little too steep, a little too tall, because it's stuck on top of there. I really think if Mercedes wouldn't have put that little nub up on top there, we might have actually been able to get it. This is difficult. Okay, next step, I removed this bolt. It's an M14, and it's really right there in ground zero for keeping the flange of the drive shaft from dropping down here. And I'm thinking maybe really this whole knob is what's in the way, but I'm thinking maybe the flange will clear the face of this enough to drop down, which will give me a little bit of movement this way and give me what I need. So let's give that a shot. Desperate times call for desperate measures. I did a couple things. One, I marked these so they're just easier to spot from all angles, which will help me place it. Secondly, I actually removed just a little bit of material here. I took that bolt out. I gave myself a little bit of a radius there. It's not nearly enough to cause any issues or weakness, but I'm hoping it's just going to help it slide down over that little stupid nub a little easier. So let's see if that works. Okay, a little wiggling, and this did indeed drop down over the edge of that flange. Over the edge of the differential face there where the bolt used to be. And this is obviously lined up, and I'm actually, feels like there's a little bit of slop there. It's starting to move. I think all I got to do is push harder. Just got to push harder. So I'm going to try that now, but it's going to take both hands. Okay, more of the same, basically pushing on the flange end of the drive shaft and hammering on this end and wiggling and pushing. I was seeing it move by fractions of a millimeter. Now it's actually sliding down noticeably. This end is getting ready to free up on... It's gonna fight me all the way, but no doubt I've got it to the point where I'm going to be able to make progress now. So again, it's a two-handed job, so I'm going to have to put the camera down for now, but looks like it's on the way. And the final piece of the puzzle was I actually put my pry bar right against the lip that was sticking out of the end, and tapped it with a small hammer, just enough to shock it forward, which put it down the splines. We're now lined up at the other end. The shaft is a little worse for the wear. I may hit it with a little black paint just to be anal, but it's ready to bolt back together. Hallelujah. And before you bolt in the front of the front drive shaft, you will want to, if you took that bolt out, you're going to want to reattach it while you have access, because once this is in place, once the drive shaft is back in place, there's no way in the world you're going to get that thing in Okay, that was no fun. I had to place it with a pair of long needle nose and then just reach up and do the best I could to tighten it with my closed end 8mm wrench. Took a while. I used a really long needle nose. So don't take that one off if you really don't have to, but I do think it was necessary to get the drive shaft out. And then to tighten up the bolts on the front drive shaft, you either have to put the car in park and do a couple of them, and then put it in neutral, rotate the differential by rotating the wheels. Would be the easiest way to do it. Just spin a wheel and it'll spin it around. Then put it in park again, or you can have somebody stand on the brake while you're tightening and then release it while you spin the differential yoke around to get to the next bolt. So all done, all tied up. Now it's time to put in the exhaust. Okay, to place the exhaust, what I'm going to do is I'm going to place the front end up in the general area it lives, and then try to weasel the tail of the thing into the clamp and get it hanging there. And at that point, before I tighten anything down, I'm going to install the front O2 sensor, which is going to be easier to get to with this disconnected and hanging a little lower. Once that's done, then I'll bolt the front up and then attach the mount and tighten up the clamp. That's just in case I can't get a video of it, which I probably won't be able to. There we go. Okay, the back is now placed. The front is reachable, so I'm going to go ahead and install the front green O2 sensor. And to do this, I'm going to unwind the sensor about 5 turns, because then when I put it in and turn it home, the cable will be under no stress at all. It'll unwind those turns. Next step, I put loosely the bolts that are the double bolt assembly that holds the right side exhaust to the bracket here. I'm just going to put the nuts on just to keep it from falling off. That'll hold it in place close enough that I won't be fighting it quite as hard whenever I'm lining up the flange and getting the bolt started, which is definitely a two-handed process that I'm not going to be able to film because I need the one angle the camera would have to be in to reach it. Bolts were placed by the extension with the 13mm short socket and the wobble, tightened up, ready to go. Now just have to place the rear black lead O2 sensor, and again I'm going to wind it to the counterclockwise so that whenever I put it in, it'll end up without any real twist in the cable. Place and tighten up the exhaust clamp. Okay, just about got it lined up. One thing I wanted to add was you might want to make sure, go ahead and drop the transmission, which will also drop the middle part of the exhaust a little bit to make that process much easier. Also, don't pull on the front section too hard. At least on mine, there's nothing really bolting it in place to the rear section. Most two-piece prop shafts I've seen do have a bolt inside the U-joint in the middle. This one apparently doesn't, so it can come disconnected, and you've got to make sure you put it back in the same alignment, or you could end up with a driveline vibration, which nobody wants. in place and buttoning up the center support bracket, you're going to want to raise the jack again, so that you'll find that you're going to have to be loosening and raising that depending on what it is you're doing. Just be aware that that might be necessary for whatever process you're doing. So got the front and back buttoned up. Now I've just got to tighten down the center support bearing bolts and place the heat shields back into place. Okay, case in point, I had to drop it just so I could slide these heat shields back into place. I went ahead and placed the transmission mount and the cross member here for the transmission mount, and this is your final lift. You want to lift the transmission back up to the point where this just is lightly making contact, just so you can place the bolts without having to strain. Okay, little warming up the transmission check, and there is zero fluid coming out here. You can see that the old plastic bellows doesn't really seal anything thoroughly. You can also see the effects of all the transmission fluid on the exhaust. And the cleaner, that's probably what's really smoking, but so far, so good. Right, the rest of it's pretty much buttoned up. Cross brace, put this cross brace back in. I did notice the exhaust was drooping a little close to it, so I loosened up the two bolts and raised the center section, just manually just wedged it up and retightened the bolts, which is all it takes to hold it in place. These are a little bit structural, so keep in mind, otherwise you're going to end up with a strange buzz in your midsection. You're not going to be able to figure it out. Okay, now just have to put on the plastic splash panels. Okay, one other detail I should mention is that having had a prodigious leak in the transmission, it was burnt onto the exhaust, and it was just generally nasty down here. So I cleaned it up as best I could, mainly so if I look under here and see a stray drop, I don't have a heart attack. This will also prevent it from smelling strange and like burning transmission fluid every time I drive the car. Although I didn't probably get all of it off, but in another world, that's all just rust proofing, so not a big deal. Okay, sitting level, waiting for it to come up to temperature. We're 5 degrees C short and climbing. I've already pumped a quart of fluid into the transmission, figuring that's about how much I lost. When we hit 45, I just pull the plug, wait for it to quit dripping, put the drain plug back in. So nearly completed.